Welcome to the another lecture of Fundamental of Electrical Engineering. So today we'll start with Kirchhoff's law. So basically all of you know the Kirchhoff's law is classified into two types. One is Kirchhoff's current law, that is KCL, and another is Kirchhoff's voltage law or mesh law, that is called KVL. So we'll start with the Kirchhoff's current law, that is KCL. So you can see here the definition says in an electric circuit for any of its nodes at any time t, the algebraic sum of branch current leaving the node is 0. Okay. So from this definition you must have the question that what is node. Okay. So basically as you know, our electrical circuit will have two different type of element. One is active element or passive element. So any two elements that may be active or passive, so the junction or meeting point of any two element is called node. So you can say that meeting point of two or more than two element is called node. Suppose I am taking here one inductor, that's L, and I am taking one voltage source here. This is active source. So in this here also I can take one resistor. So I am putting is V, and here I can take one capacitor also. Okay. So the meeting point, so this junction is called node. So basically this is called node. Let I am giving this node is name as A. Okay. So what KCL is saying? So in an electric circuit for any of its nodes at any time t, you can take any time t, the algebraic sum of branch currents leaving the node. So I can put here some currents. Let some current flowing here. Let I1 amount of current is flowing towards the node. I2 amount of current is again flowing out from the node. Here I3 amount of current is entering, and here I4 amount of current is leaving from the node. So according to KCL, you can say that the branch currents leaving the node, you can see here there are two currents which is leaving the node. So one is your I4. So you can see that the algebraic sum of leaving currents equal to 0. So in this particular node A, you can see that I4 is leaving. So you can write down I4 is leaving. Again I2 is leaving. I4 is leaving from the node and I2 is also leaving from the node. But I1 and I3 is entering. So as I1 is entering to the node, you can say that minus I1 is leaving. You can see here, if I1 is entering, then I can say that minus I1 is leaving. Similarly, if I3 is entering, you can say that minus I3 is leaving. So as KCL is saying, algebraic sum of branch currents leaving the node. So which is leaving now? You can see that here I can write down minus I1 minus I3 is equal to 0. So in this way I can write down here I4 plus I2 is equal to I1 plus I3. So here I can mention if any current is leaving, I is taking as positive. If any current is entering, then I am taking as negative. So finally from this equation I got I4 plus I2 equal to I1 plus I3. So you can see here I4 and I2 are leaving, I1 and I3 is entering. So from this we can conclude that so sum of leaving current is equal to the sum of entering current. Sum of leaving current is equal to sum of leaving current. This is nothing but the Kirchhoff's current law. Then we will move towards the Kirchhoff's voltage law. So it is called Kirchhoff's voltage law or Kirchhoff's mesh law. So this Kirchhoff's mesh law is only defined in a closed path that may be mesh or loop. So details about mesh and loop I will discuss when I will teach the nodal analysis. So this what is Kirchhoff's voltage law? KVL's statement. The statement of the KVL is that in an electric circuit for any of its loops at any time t, the algebraic sum of branch voltages around the loop is 0. So basically I can say that so loop is a closed path where this I have to calculate the voltages. Suppose I will take one circuit. You can see here I am taking one circuit. So there is a voltage source is there and one resistance is there. Let the resistance value is R1. Then another resistance value is there. I will take R2 and I have a voltage source here. I have a voltage source here. Let this voltage source is V2 and this voltage source is V1 and there is R1 and R2. I do not know what is the value of V1 and I do not know what is the value of V2. Let I am assuming that my current is flowing, the current I is flowing from anti-clockwise clockwise direction. So when current I is flowing, there is a voltage drop here. So as current is entering here, I will put positive. Current is leaving here, I will put negative. Same I amount of current is flowing here. So entering I will put plus and leaving I will put minus. And as there are two batteries, we know the direction of the sign of the battery. This is negative, this is positive, this is negative, this is positive. Okay. So when I amount of current is flowing, so let there is a voltage drop across R1. Let this the voltage drop is V3 and the voltage drop across R2 is V4. So and we know the voltage drop in V3 is nothing but your I into R1 and the voltage drop across R2, that is V4, nothing but your I into R2. So as we discussed in the previous videos, if we apply KVL, if I want to find out what is the voltage drop across this closed path and if my direction is in the clockwise direction and I can start from anywhere, so I will go from here. So first I will get minus to plus, so I will get here plus V1, then plus to minus. I am going in this direction, getting plus to minus, so I will get minus of V3. Again I am going from plus to minus, so I will get minus V4. Then again I am going from plus to minus, so I am losing something, so I will get V2 equal to 0. So if I replace this one, so V3 I can replace with I into R1. Similarly V4 I can replace with I into R2 and minus V2 equal to 0. So here you can see that in this closed path, all the voltage or all the branch voltages, all the algebraic sum of all the branch voltages is equal to 0. This is nothing but your Kirchhoff's voltage law. Thank you for listening.